Sure. Hi, everybody. Thanks for waiting. I hope you can all hear me. Go ahead and maybe just give me a yes in the chat box if you can hear me okay. We're just waiting to get started for a few more minutes. Oh, great. Thank you. Okay, I have 301, so I think we're going to go ahead and get started. And thank you for everybody for letting me know that you can hear me. I wanted to give a little introduction first before we start the program. And I wanted to welcome Ron Rosano, NASA Solar System Ambassador. He has been very generous with his time and done many programs with us over the years. So thank you again for being here, Ron. Let me just give you a little bit of background about Ron. He was inspired by the Apollo flights to the moon and has closely followed NASA ever since then. He's also been active with the San Francisco amateur astronomers from the 90s on. He's built a 10-inch Dobsonian telescope with John Dobson himself in 1993. He also has worked with the Astronomical Society of the Pacific, their Project Astro in 1995, and since then has conducted many astronomy lessons and led a lot of discussions with students from K to 12, as well as the public in settings like this in the libraries. Ron also serves on the Advisory Council of ASP, which is the Astronomical Society of the Pacific. He currently works for a small real estate company, is a avid photographer, and pursues interests in both music and the outdoors. And also, Ron has reservations to fly into space one day on a commercial, with a commercial company. So, all right, well, welcome, Ron. I think we are ready to get started. Let me go ahead and give you the floor.
All right. Thanks, Teresa. Hey, everyone.
Okay, thank you.
Hi, everyone. Thanks for joining us. Teresa, thanks for having me back. This is nice to be able to do this live online since we can't meet in person. And thanks, everyone, for your interest in Mars and NASA's new rover called Perseverance. I'm going to jump right into a slideshow presentation and give you some background and explain what's happening. How's that appearing all right for everyone? Teresa, can you see that okay? Let me see if it says so in the chat. Great, thanks. So NASA's has a rover on the launch pad in Florida, and I'm here to talk about it and breaking it down into three sections, really. First, talk about how far away Mars is and how difficult it is to get there, and try and give you an idea of why it takes months and months to get to Mars. Then talk a little bit about the robots at Mars today, several in orbit, several on the surface, and then we'll go into finish up with what the newest Mars rover named Perseverance is going to be doing on the surface. So there's an artist's depiction of Perseverance on the surface of Mars. And I want to just begin by giving you an idea of the scale of Earth and Mars together. You know, if you do a search for solar system, you get images like this. Yes, they've got all the planet names right and shapes and, you know, order from the sun, but what you don't get is how far apart they are. And they are, in some ways, unimaginably far apart. So if you're going to size the solar system to true scale, this is what you get if you had a 9-inch soccer ball. Jupiter would be about as big as the swirly rubber ball there that's 1 inch in diameter. Then there's Saturn, Venus, and Neptune in the middle sizes. And then they're at the very bottom, Mercury, Venus, Earth, and Mars. Earth and Venus are the green beads. Compared to a 9-inch soccer ball, they're about 2 millimeters in diameter, just a little bit larger than the head of a pin. So Earth's diameter is around 8,000 miles, and it's using this scale to give you an idea of what its orbit is like. The International Space Station orbits about 250 miles, but really you only need to be about 50 miles off the surface to be above 99.999% of the atmosphere and into space. So if we move away from the Earth, we bring the moon into view. The moon's average distance is about 240,000 miles, about 250,000. Moving farther on out, you could fit moon's full orbit in this view. And that's about 500,000 miles. Moving even further back, you get enough room to fit in the orbit of the planet Venus. So when Earth and Venus are on this same side of the sun as close as they get together, they're about 26 million miles, so about 50 times as much as the diameter of the moon's orbit. But you can still see the relative size of the moon's orbit there in the blue dashed line for Earth's orbit. Moving farther back, we use a little star for the sun in the middle and pull in the orbits of the 4 rocky planets close to the sun. So that's going out from the sun, Mercury, Venus, Earth, and Mars. We'll leave Mercury and Venus out of this for a minute for the rest of this. And you can see here relative distance, average distance of Earth and Mars. And you can also see that Mars takes about 22.5 months to make one revolution around the sun. So a Mars year, what's called a sol, is about twice as long as an Earth year. This is a big factor in how to get to Mars. So what if we want to travel to Mars? Can we just go straight there? Not really, because the most economical way is to fly in an ellipse. So you just really enlarge the circle of the orbit and you give the spacecraft a little boost. We'll use this white ellipse as the path of the spacecraft, and the little white dot will represent the spacecraft. And let's see what happens when we travel to Mars. So start off, a month later, you can follow Earth and Mars as they move in their orbits. So what they're really doing when they're sending a spacecraft to Mars is they're sending it to a point in space where Mars is also going to be at that exact point in space 8.5 months later. So now you've got to Mars. That's about how long it takes. You could go somewhat faster, but when you go faster, you have to carry more rocket fuel to make it go faster. And you're also going so fast, you have to carry more rocket fuel to make you slow down when you get there. So it's a very delicate balance between how fast you get there and how big the rocket needs to be. Now, once you're there, it's difficult to go straight back because as the months go by, Earth is moving over to the other side of the sun. So there aren't really any options for returning to Earth until you get to around 2 years later. And similar to the way the spacecraft traveled to Mars, it travels on a curved path to Earth, and it arrived back at Earth almost 3 years later. So that's the profile of a typical flight back and forth to Mars. And it's not something you could do in half a year or even a year and a half. So there's a couple of profiles of what it looks like if you look at it in numbers of days. You could do a short stay at Mars there on the left, or you could do a long stay. And what's interesting there is to look at the amount of days each of these missions would take. There at the bottom, if you do the short stay, it'll take almost a year to get to Mars. You could spend 40 days on the surface, and then almost a year to get back. So that's a long time to be away for a short period of time on the planet. The longer stay, there on the right-hand side, takes you about 6 months to get there. And then like we saw in the diagram just before this, you could stay on Mars for a while, but then you have another 6 months to come back. So it's really a 2.5-year trip in total. So there are a lot of complications about being away from the planet for that long if you're trying to do human travel. One of those difficult things is that astronauts lose weight mass and blood volume when they're weightless. This is Don Pettit coming back from 6 months at the space station. Pretty much everyone that comes back from the space station after 6 months of weightlessness has a very difficult time walking and standing. And a real challenge for a mission to Mars is when you land there, how are you going to get accustomed to gravity again? Astronauts, when they come back from space, typically get carried off, and you won't have a big group of people there at Mars to carry you around. So in the second section, we'll talk a little bit about the robots at Mars. Mars is actually, yes, the only planet that's entirely inhabited by robots. And here's a little graphic of the history of missions to Mars, starting back in the 60s. You can see the failed missions on the left far outnumbered the successful missions on the right. And those first missions there on the right were just flybys. They weren't going in orbit around Mars. They weren't landing on Mars. They were just trying to fly by and take some pictures. And they had 3 successful Mariner missions that sent back pictures. In the 70s, we had the first successful landers on Mars, the 2 Viking landers that landed in 1975, but also more failures than successes. They were 0 for 2 in the 80s, 2 for 2 in the 90s, and then here in the 2000s, we're actually running better than we have before. Actually, say that in the 90s was actually more failures than successes. So Earthlings have spent a lot of funds and resources trying to get to Mars and have had not complete success at all. So probably less than half the missions have made it successfully. Here's an image from 2014 showing some of the spacecraft that are on Mars right now. The Opportunity rover had a long operational life. It's currently not operating. The Mars Curiosity rover landed in 2012. That's been operating since then very successfully. Very similar in design to Perseverance Mars 2020 rover that's on the launch pad in Florida. In 2014, they thought SpaceX might have landed a couple of Dragon spacecraft on the planet, but that hasn't happened. And the Mars InSight spacecraft is currently on Mars and operating. The European Space Agency and Russian Space Agency have another rover they're planning to launch in 2022. So early on, they wanted, the scientific thinking was to see where water has been, follow the water, and then determine if those conditions could have supported life. And now they're seeking signs of life for the first time. So one of the important things that the Mars 2020 rover is going to do, it's going to actually look for evidence of life, and that's one of the big hopes and mission. To give you an idea of scale of the orbiters, or of the rovers, there at the bottom left is the first Mars rover that called Sojourner, about the size of a toaster oven. That's one that's at the bottom. The middle-sized one, those were actually, they had sent 2 rovers of that size. Opportunity was the last one that was operating. And there on the right-hand side is a mock-up, a scale model of the Mars Curiosity rover that's on the surface now. The Perseverance rover is similar in size. And here's a full portrait of all the spacecraft, both that have failed and been successful in landing on Mars. So one of the really difficult things about landing on Mars is touching down softly on the surface. The spacecraft is traveling, tens of thousands of miles per hour through space. Perseverance will launch in July and land in February. And then once it gets to Mars, there are some serious challenges about how to land it safely on the surface. And the engineers at the Jet Propulsion Laboratory that designed and built the rover have come up with some very clever ways to do that. Here's what they do.
When people look at it, it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy.
Stelzner, by the way, is a graduate of College of Rennes.
It is the result of reasoned engineering thought, but it still looks crazy. From the top of the atmosphere down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away from us. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror, because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divert maneuver. We fly off to the side,
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater, right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the sky crane maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit it on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage is in a collision course with the rover. We must cut the bridle immediately and fly the descent stage to a safe distance from the rover.
So that all went according to plan. Video was made for Curiosity rover, and here's a few images from that landing. This is the heat shield after it was detached on its way down to the surface. And NASA thought it'd be great if they could get pictures, so they coordinated the arrival of the Curiosity rover with another orbiting spacecraft that flew right over the landing site, and as the rover landing was going by in one direction, the spacecraft was going the other, and they calculated exactly where to aim the camera, and they got a great photo of Curiosity under the parachute. After Curiosity landed, this is one of the early views of Mars. And here's a view from under the deck of the rover, and you can see the wheels there and the little holes in the wheel were meant to spell out JPL in Morse code. Here's an animation of Curiosity rover doing some of its scientific work, analyzing parts of the surface of Mars. One thing it did, it drilled into the surface, collected samples, dropped the samples inside the body of the rover, where there's a miniature chemical laboratory that can identify all the components, atoms, molecules of the soil. Curiosity also had a laser that it would fire at rocks on the surface, and it could analyze the dust that came off of the surface and tell what components the rock was made up of. Here's some data from Curiosity over a Martian day. So what it's showing is the temperature on Mars. There on the low end on the left is at nighttime, and during the course of the day, the temperature rose up to about a high of about 37 degrees Fahrenheit, so just over freezing on Earth. And at night, it gets down to about minus 100 degrees. So there's a very big swing in temperatures in the air and on the ground Mars, and that's one of the challenges the team has to deal with. Here's a picture of Curiosity. This is actually an assembly of many pictures that the camera on the end of the arm of Curiosity took. And by moving the camera around, the engineers and photo specialists were able to create a selfie. So there's a selfie from Curiosity. So what's Perseverance going to do? It looks very much like Curiosity. It carries an entire suite of science instruments, cameras, soils analysis, drills. Here's some of the things that are on board. One interesting thing is the MOXIE. There inside it's an experiment that's meant to take Martian atmosphere and process it into oxygen. And if they could do this successfully, they're hoping to be able to do that on a further human flight and create oxygen for people to breathe. There are 23 cameras on board, some of them for engineering, and checking the functions of the various parts of the rover. And for the first time, the rover is going to have extra cameras operating during the entry, descent, and landing. So if all goes well, we'll be able to see the parachute deploy and the heat shield come off the bottom of the rover, and see a lot more of all those dynamic parts of the mission as the rover gets lower down onto the surface. Here's a little breakdown of the MOXIE. It'd be really important if they could, if this experiment would work. It could be critical to a human mission on Mars, is to be able to take something like this and make oxygen. It'd be a lot easier to make oxygen there than to carry a lot with you along the way. Here's the rover about, let's see, I think this is 6 or 9 months ago. Once it's all built and constructed, they do test driving. That's at the Jet Propulsion Laboratory in Pasadena. I had a visit there a couple of years ago. This is one of the wheels that they were testing. They had issues with the wheels. You can see where it's cracked there. That's what happened to the wheels on Opportunity. It got some damage to them, and they redesigned the wheels for Perseverance to make sure that doesn't happen again. This was an early wheel design. The engineers there thought it would be fun if, as the rover drove along, it could just spell JPL, 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 JPL on the Martian surface. They actually got shot down and weren't able to do that. So that's why they ended up, as you can see in this picture, with the little squares that spell JP out in Morse code. Here's a close-up of the mast camera on Perseverance. The laser cameras, they're in the larger circular part of the top. Down below that, there's 2 square cameras that they'll use for science, I think, and then 2 outside of those, 2 round cameras for navigating. This is a time-lapse video of the arm in motion. So there are a large suite of instruments at the end of the arm that move around, and each can perform different functions as it reaches down to the surface. Once they're finished with testing, the rover gets packed up like this. All the wheels there are wrapped. That'll come off before launch. And if you look closely, down in the gold square below center, there's a helicopter mounted there. So one of the really cool things that this mission is going to do is it's going to attempt to fly a helicopter around Mars, a drone of sorts. This is the back shell and the heat shield on the left, air shell in the front. These are the parts that make up the enclosure for the rover. There it is. I think that's it. Might be in Florida, getting final assembly before they put it on the rocket that will launch it. So the ring at the top with the gold balls, that's the crew stage. So that keeps systems alive and provides fuel on the way to Mars. There's the whole package stacked together. And as of about a month ago, it looked like this, Curiosity inside the nose fairing for the rocket. So one new thing they're going to do is improve landing techniques. So they're going to compare photos taken from orbit to photos that the rover is shooting while it's coming down, and they'll have the ability to divert around anything dangerous if it comes up, if it sees anything. This is really important technology because one of the key issues or key things for bringing people to Mars is flying supplies before people get there. They want to make sure that all the stuff is in place before they send humans there. So a lot of the things they do for this mission have important implications for later missions. Here's a picture or an animation of what the helicopter will look like on the surface, and then the rover as well. And you can see over on the left there's some tubes. One of the really interesting and exciting things about this mission is that the rover has built in a sample collecting system. And it's going to collect soil samples in tubes on the surface. Here's a picture of the actual helicopter itself. It weighs about 4 pounds and is about 1 foot high. And here's a picture of a prototype sample collection tube that the rover's carrying, I think, 35 or so of these tubes, and it's going to collect samples from different places, leave them on the ground, and then the idea is that in the future, probably 4 years from now, another spacecraft will go and collect the tubes and bring them back to Earth. So, just about the last slide here. So there was a lot of work to do up until this point in understanding the surface, and there's still a lot more to do, but we've made a lot of progress. I'll close with that one. That's a little history of all the different missions that JBL has launched, dating back to 1958. They ventured all over the solar system. So there you go. That's great. Hopefully, interesting overview, and glad to have some questions and share some other things too if you'd like. And I see you were asking, how did I get that fancy title and what does it all mean? The NASA Solar System Ambassador Program is a volunteer program. I think there's maybe 500 people around the country that have signed up for it. All that's required really is an interest in NASA missions and willingness to take time to share those with people. And I've enjoyed it a lot. I've been doing it, it's been about 12 years now. And we get some nice perks from it too, like the pictures I had there from JPL. Got to visit the site there and see some of the work that they're doing. Anyone else with questions? Has water been discovered? Thanks, Craig. They have evidence of water. They haven't found actual water. There were some interesting things they found in pictures that looked like it might have been liquid or kind of mushy, slushy material that had appeared on this very steep slope. And they thought, oh, maybe that's some kind of, there's water as part of that. They ended up finding that it wasn't, but they know for sure that water did exist on Mars. And that's one of the important things about where Perseverance is landing in the Jezero crater. Through all the work they've done, they know that Jezero crater once did have a very large lake, about as large as Lake Tahoe. And there's instruments on the rover that can use radar to sense below the surface. And some scientists think there could be liquid water, deep below the surface of Mars. And that's one of the results they're hoping to see is that'd be a fantastic find. let's see. Is Mars 15-ish light minutes away? Yes, about. But this is another challenge of operating on Mars, is that sometimes Mars and Earth are on the same side of the sun, sometimes they're on the opposite side of the sun. So if you're, it's about 15 minutes, it'll be about 15 minutes away when Perseverance lands in January. Then as they get farther apart, it's more like 20 minutes. So that's a real challenge for human presence on Mars, is you want to land there and fall and injure yourself and say, hey, Houston, I think I just broke my leg, and then you'd have to wait 20 minutes for them to hear you, and then another 20 minutes for that response to come back to you. So you can't, even at the shortest distances, I think it's about 15 minutes round trip for a signal. So it's if you're on Mars, you can't really have a conversation. So most everything really has to be automated. Let's see, have rovers ever crashed? Thanks, Lisa. Let's see, I don't think NASA's crashed a rover. The first rover they attempted was the Sojourner rover, and then Spirit and Opportunity, the rovers after that, and Curiosity. So they've landed 4 rovers on Mars, all successfully. So how will water be synthesized on Mars? That I'm not sure of. So that may be better posed for Google search. And Owen's asking, are there as many air molecules on Mars as there are on Earth? Because then how would the helicopter work? Yes, there's, I'm not sure about the count of molecules, but the thinness of the Mars atmosphere makes the helicopter really difficult to fly. So there is about 1/100th of the atmospheric pressure on Mars. So you could have winds that are really blowing, but they wouldn't like ruffle your shirt or your jacket or anything. And one thing about the rover is that there's 4 very large blades. They're spinning very, very fast because the rover is very lightweight. They've calculated that it will actually fly, and it's designed to fly. One thing that really helps is that the gravity on Mars is, I think, around 1/3 or so of the gravity on Earth. So it'll be easier to fly in some ways because of that. What else? Does Mars have frozen water? Not that they've found, as far as I know. And when are Uranus and Neptune going to get a mission? They've only had a Voyager flyby. Yeah, that's exactly right. I don't know if I don't think there are any missions in the books or planned for the Uranus or Neptune. There is a mission that's funded, that's being designed to go to one of Jupiter's moons. They call the moon Europa. And we're calling that mission the Europa Clipper. So if you do a search for Europa Clipper, you can find out more about that. And Mark asks, how can people have successfully landed on the moon yet have not yet successfully landed on Mars? Well, there are many, many challenges. The Apollo astronauts took about 3 days to get to the moon, and they had constant contact with Earth. The time delay for conversation is only about 1.5 seconds or so. It's very risky. I think Neil Armstrong had said that they thought their chances of successfully completing Apollo 11 were about 50-50, and there was maybe a 10% chance that they wouldn't even make it back to Earth. Mars's challenges are distance in a lot of ways. That's and material and the length of time you'd have to stay there. You know, it's easy to bring 3 days worth of food and water, like we did to the moon, but to bring 6 months or years worth of food and water is a much more challenging thing. And let's see. What happens if Mars dust gets into the gears of the rover? Yeah, that's the Mars dust has posed problems for Curiosity on the surface and the other 2 rovers, Spirit and Opportunity and Sojourner. They designed the gears. I'm guessing the gears are designed to be sealed against debris like that from getting inside. But one thing that happens with everything on the surface of Mars, there are winds on Mars, and the winds blow dust around. So there's pictures of Curiosity, and you can see where the solar, actually not Curiosity, but of Spirit and Opportunity, where the solar panels on those 2 rovers over time had dust accumulate on the panels, and it really reduced the amount of electricity that those rovers could generate. Fortunately, there was also little dust storms that would occasionally blow the dust off the panels. So that's been a challenge in the past. Curiosity and Perseverance don't use solar panels for power. They use a nuclear generator. It's tightly sealed plutonium that gives off heat, and they turn the heat into electricity. Hey, Marcia, you're asking to turn the volume up or speak louder. I can speak a little louder for sure, but we're just about out of time, but I'll take the last few questions. And I'm glad to take as many questions as you guys would like to send over. How many rovers have been sent to Mars? So this would be the 5th by the U.S. And yeah, I think that's it.
Ron, we have one more question.
Here.
I'll just read it to you. It's a long one. It says, you mentioned something about rerouting around obstacles during landing. Would the robot recognize the obstacles and correct, or would NASA employees correct before starting to land?
Oh, all those corrections happen on board the rover, or on board the landing vehicle. Because it takes about 7 or 8 minutes for commands to reach Mars, they can't command it from the ground. The time lag is just too long.
Okay. Thank you so much. I think that might have been our last question. One more, one under the wire. What other country is focused on Mars? Someone is asking.
Yeah, there's several countries. The European Space Agency, which is a conglomerate of European countries, they're planning a rover to launch. They're supposed to launch this year with this conjunction of Earth and Mars, but they've had some difficulties, so they're going to have to wait till they come around again. So they're going to plan to launch in 2022. The Indian Space Agency, ISRO, has an orbiter at Mars. So India has a spacecraft that's orbiting Mars and sending data. It's called Mars, let's see, it's got a cute acronym though, it's called MOM, the Mars something orbiter. Anyway, I have to look that up.
Okay, and then someone I can answer this one. Yes, this is being recorded and you can watch it later on our YouTube channel. So just look for Larkspur Library's YouTube channel. You'll be able to watch it there. And then I see someone's asking, who do you think will get to Mars first?
Who do you think will get to Mars first? That's probably a student in school today. Somewhere out there, maybe a middle schooler.
Maybe someone who's attending this webinar.
Yeah.
That would be great.
Someone college age. I don't know. It's hard to say.
Yeah.
It's could be likely that would be a multi-country mission. Just like the International Space Station is built by 15 different countries. Great example of cooperation around the world. Getting to Mars could best be done by many people working together. So.
Absolutely. All right. Well, thank you so much for a really informative talk. And I learned a lot. I'm sure everyone else did as well. So we have you back again next month, August 19th, same time, starting at 3 o'clock. And we'll have the registration open for that very soon. So please watch our website and social media for announcements about that. So thank you again, Ron. And we'll see you. Did you have one last thing to add?
I should add that the launch date for the rover is July 30th. So it's coming up in a couple of weeks.
July 30th.
Yes, and it ends August 14th. So if they miss that window, then they're going to have to wait 2 years, and they don't want to do that. So it'll be in the news, and there's all kinds of NASA resources. If you search for Mars rover or Perseverance, you can find all kinds of, there's great movies about assembling it and what it's doing. And one other question here, what if the rover crashes? Then we need a lot of very sad people.
Okay, wonderful. So we look forward to seeing you next time, and hope to see everybody
Thanks so much. Thanks.
again. In the meantime, yeah. Okay. All right. Thanks, Ron. Thank you, everyone. Bye-bye now.